want us to look at a concept called margin of error, confidence interval, and questions like, how big does your sample have to be in order to get a certain accuracy, called the margin of error. Right. So that's the kind of 3 goals that I want to get done right at the beginning. Once I've done them, we're going to go and look at some of the homework questions, and then we'll move on to the second chapter 5. We've kind of covered most of the stuff that's in there. You remember we had to read through all those PDFs and we talked about all the things that were going. So really the second thing is just asking you questions about it. So let's look at a guy, number 1. His full title is the conservative margin of error. And I'm going to call it CMOE, because I don't want to have to write conservative margin of error all the time, right? Now, what is this guy? Well, can you imagine that we are interested in a local election? The mayor of Bremerton, right? Something like that. And before the election, they do things called polls. Do you know polls is just another name for a survey, right? So they do a survey, a poll, and they collect a sample. And the sample that they collected was 500 people. And they just kept the question nice and simple, as we know is the best thing to do. And they went and said, are you likely to vote for candidate A as mayor? And the percentage who said, yes, I'm going to vote for him, was 51%. And the newspaper next day had a headline saying, candidate A is going to win the mayor's election. This is in a poll of 500 people. And a lot of people who read that article would say, oh, I didn't like him. I wanted candidate B. But if candidate A is going to win, why should I bother voting? That is called voter suppression. And unfortunately, it's used a lot. What the idea behind it is, and the reason they do it is because it works, is that you make sure that there's polls as close to the election as you can that can dishearten the other guys. Your guy's not going to win. The other guy's going to win. Look, he's going to win. If you get 51%, aren't you going to win? Because you only need 50% plus a person and you've won, right? So you're going to look at it and say, I'm just not going to bother. And can you see why that could be a self-fulfilling prophecy? Because if people who think their candidate's not going to win, more of them don't turn up. And if they don't turn up, doesn't candidate A win? See how sneaky that trick is? So you have to be really careful when you hear this information without them telling you a very important extra thing. They should tell you the margin of error. So let me show you the calculation for the conservative margin of error. It's 1 over the square root of the sample size times 100, and that way you get a percentage. So I go to my calculator and I find out what 1 over the square root of 500 is times 100%. When I do that, I get 1 divided by the square root of 500. It's that guy. And I'll times them by 100. And the answer I get, and I'm just going to round it off, is 4.5%. So when they tell you their poll, right, they should be saying 51% plus or minus a margin of error of 4.5%. What this 4.5% does is, can you imagine if you asked 500 other people in Bremerton, you might not get 51% of them voting for that guy. Might it be 59%, but could it also be 45%? So what the margin of error does is it gives you an idea of how accurate your prediction is. So it's 51%, give or take 4.5. So in one side, it could be, oops, I can't count. On one side, it's 46.5%. And the other side, it is 55.5%. Now that I've given you this range of values, do you see that it isn't guaranteed that candidate A is going to win the mayor? Couldn't he get as low as 46.5%? In fact, if he got that, wouldn't he lose? Because we'll assume it's a two-horse race. Right, he could win by a lot more, but couldn't he also lose? Do you see why this margin of error now gives you better information to work with? It's now much clearer. In fact, when they do that, they use a phrase, something similar to too close to call. When the elections happen, if you have that phrase being called, you know, Colorado is too close to call, right? We don't know if it's going to be a Republican or a Democrat that wins it, right? Too close to call. They also will use a phrase within the margin of error. And it's just the same idea, right? So if something is within the margin of error, doesn't that mean you can't really for sure, you know, on your heart and your hand, say, I am certain as far as I can be that candidate A is going to win. This interval that I've got written down here, the 46.5 to 55.5, this is called a 95% confidence interval. Interesting name. 95% confidence interval. And you say, well, where did that 95 come from? They're all 95, at least when you use a conservative margin of error. And so what that means is, do you see this interval that I've just found? We are 95% sure, right, that the true answer is somewhere in that region. But we're only 95% sure. Doesn't that mean that there's a 5% chance that our prediction is way out, not even vaguely close to what happens? Now, can you imagine that you had, well, you do, you have 50 states. That's roughly 1/20th. If 50 states all came out with the same result, 2 of those states would end up having results that were completely different from what the pollsters thought it was going to be, just by statistics. But why does that happen? If you ask 500 people, couldn't you just get a lot more Democrats than really live in Bremerton, just by coincidence? Or a lot more Republicans who live in Bremerton, right? Doesn't really matter. But can you imagine that just by sheer, for want of a better word, bad luck, your sample might not be quite as representative as it could be? And that 95% is showing that uncertainty. That even when we have an interval, we can't guarantee that the right answer is in that range. All we can say is that we're 95% sure that it's somewhere in that range. So let's have another election in a equally small town, and candidate A also got 51%, but this time the sample was 5,000. If you ask 5,000 people in a sample, do you think you should get a more accurate prediction? Do you think you should be right or closer to being right more often than wrong? Would that seem reasonable? Right? Yeah, and it is. So let's see what the conservative margin of error should be. Well, if you're more accurate, shouldn't this number be smaller? Think of this as being your error band, right? And 1 over the square root of 5,000 times 100%. That gives me, but it will in a minute, 1 divided by square root of 5,000, and it 1 divided by square root of 5,000 times 100. and I get 1.4%. And that tells me that it's 51%, give or take 1.4%. And now we are looking at 49.6% or 52.4%. And that's my 95% confidence interval. Can the newspaper say candidate A is going to win? Based on the numbers in this interval, can you say for sure candidate A is going to win, or is it still too close to call? What's your feelings?
I'd say it's still too close, but it is right on that edge where they could say it if they round up the 49.
Oh, I guess so. You're right. I didn't think you rounded up. Yeah, but if we use just the numbers we've got, isn't there still a chance that the other guy could sneak in? Right? I mean, because if candidate A gets 49.6% of the vote, isn't the opposite of that means the other candidate gets 50.4% and wins, right? If it's a two-horse race, which we'll assume. So last chance. The newspaper is desperate to find out if there's evidence here. And just by sheer coincidence, and it really is, they still managed to get 51%. I would highly doubt that. Can you imagine every time you do a sample, you get slightly different answers, which is kind of what's reflected here. But they got that. And the conservative margin of error is now 1 over the square root of 50,000 times 100%. And what we've got now is 1 divided by the square root of 1,000 times 100. And the answer we got, and I was hoping to get that, let's just call it 0.4%. And so the 95% confidence interval is 51%, give or take 0.4%. So that would be 50.6% to 51.4%. In this story, couldn't you have a newspaper article and say, we believe candidate A is going to win the mayor's election? Aren't all of those numbers bigger than 50%? And that means you win the election. Does that guarantee candidate A wins the election? Guarantees, 100% guaranteed. Wait a minute. What about this 95% confidence interval? Doesn't that mean that whatever interval we've got, we're only 95% sure that the real answer is inside it? No matter how big we make our sample, isn't there a 5% chance we just screwed it up and the right answer? I mean, it could be huge, but couldn't it also be 40% as well when we screwed it up? So statistics never tells you guaranteed 100% anything. And if someone says that statistics is saying that to you, they're either telling you a deliberate lie or they don't understand how statistics works. Statistics tells you on balance of probabilities what is the most likely thing to happen, and they also give you range of values so you can make a judgment call about how strong you think that evidence is, right? But it doesn't mean 100% right, because if they were 100% right, we wouldn't bother with elections. Wouldn't we just have a couple of polls and whatever they said, call it good? Right? That's why we have elections, to really find out what people think. Are we go with it? Now, I'm going to use the numbers that I've got there to show you an interesting property. This is our sample sizes that we used. And here is the conservative margin of error, right? So when we did a sample of 500, our margin of error was give or take 4.5%. When we upped it to 5,000 people, it went to 1.4%. And when we did 50,000 people, it became 0.4%. Can you see the following truism? The bigger the sample you use, the smaller the margin of error. Would you agree that that makes sense? That the more people you ask, think of margin of error as a number that gives you an idea of, how accurate you are. Make sense? Any questions about that? Because I've one more thing to do in this topic, and then we'll look at a homework question. So we go with margin of error and how it gives you a confidence interval that gives you an idea of what's going on, at least to a certain degree of confidence. Right. Here's a question that you sometimes want to know. I am going to conduct a poll or a survey, and I want my margin of error to be quite small. In fact, I want my margin of error, my conservative margin of error, I want it to be 1%. And the question is, how big does my sample N have to be? So before I've even conducted my sample, I'll know how many people I need to ask to get that, right? In this case, 1%. And how does that work? Well, here's the formula. N is equal to 1 divided by the margin, the conservative margin of error, squared. So that's the formula. The number of people in your sample is 1 divided by the conservative margin of error squared. But you have to be careful. Where the conservative margin of error is written as a decimal. Okay. Conservative margin of error, I want it to be 1%. Would you agree as a decimal, it's 0.01? That's what I mean. So how many people do I need in my sample to get that accuracy? 1 over the conservative margin of error squared, which is, I need, is it 10,000 or 1,000? Let me double check.
10,000.
Oh, I got it right. So I need 10,000. Do you see how big your sample has to be then if you want a margin of error of just 1%? So whatever I ask them is going to be that number plus or minus 1%. You see the plus or minus, the margin of error doesn't care what the question is. Right? It's going to be, if you make a sample of this size, it's going to be 1%. Right? And if you make a sample of 50,000, it's going to be 0.4%. Are we comfortable with that? Turn it into a decimal and then just, it's a little formula to remember, and you are good to go. So let's show you some questions. I didn't do that. Let's do a couple of questions based on what we've just covered. Suppose you have a random sample of 558 Americans and you ask them, when a person has a disease that cannot be cured, do you think the doctor should be allowed to, by law, to end the patient's life by some painless means if the patient and his or her family request it? Which is a fancy sentence for, are you in favor of euthanasia? That's what they call that process, right? Do you know that there are some countries in Europe where that is legal, where you can actually do that? As far as I know, it's illegal in America, isn't it? The person who does it gets charged with assisted suicide, I think is the jargon for it. On this sample, 74% said yes. Okay, and it asks us to calculate the conservative margin of error, right? So that's the guy that goes there. What would my calculation be to get in this particular data set?
1 over the square root of 558 times 100%.
And to 2 decimal places, which is what I believe they're asking for here, it's 46.57. And the percentage sign is already there. Now, when they ask you to make a 95% confidence interval, won't that be, what? That's not right. Excuse me, I hit 11 there instead of 1. Don't know what my buttons were doing. Let's do that again. That's much better. Well, shouldn't I have been worried if I was paying attention to a 46% margin of error? I mean, isn't that a bit like saying plus or minus 50%, which means from 0 to 100, right? So I should have known that. Okay, now you've got 74% and you want to do the 95% confidence interval. So won't you just go 74, take away 4.23, and in the other side, I'm not doing the calculate. I'm not doing the answer. I'm doing the calculation. And on the other side, it's going to be 74 plus, where are we? 4.23. Although I haven't calculated those numbers, very roughly, isn't it somewhere between 70 and 78%? So if that data was collected fairly and unbiasedly, then we would be correct in saying the vast majority of Americans agree with euthanasia, which is what that's about. I don't know how accurate this data is. When they do questions and it's data that they've collected, they normally have a little thing that you can go and look it up, you know, a report. So I'm wondering if this was just created as random. This one here is just conservative margin of error, right? So it's 1 over the square root of 2100. But they ask you to give the answer as a proportion. What will be the difference then?
Leave it as a decimal.
Make it a decimal. So don't call it 4.2% or whatever it is, call it 0.042, for instance, if that's what you had. Are we comfortable with this guy, margin of error, 95% confidence interval? I know we didn't get a shot because they didn't have a question about how big the sample is, but that's still important to know. So I'm happy with that. So let's look at sampling methods now. And I'll close this one off. We'll go back in. And I'll do a quick scan through. Most of these questions, do you see they're just stories and you pick an answer? Right, so can you imagine that these were homework questions? If these were homework questions, I wouldn't see working for these. Wouldn't I just see the answer that you picked and that would be it? See the question I just finished doing, the 95% confidence interval one in that one. If you got that question in a test, you should really show me the working, right? The 1 over square root and what you did to get that answer, right? So we'll talk more about this tomorrow when we talk about what your test is looking like and what I'll expect from you. But there's just a quick example of it. I don't know if I've done this one. I definitely have done it with my other class, but I may not have done it with you. Have we done this question about local government? Is this all new stuff? Okay, makes life easy if it's brand new. We are going to look at all those terms that we talked about yesterday, right? Sampling, bias, population, sample, all that good stuff, right? A local government wants to determine whether taxpayers support increased local taxes to provide more public funding for schools. So they randomly select 500 school children from a list of all the children enrolled in local schools, and then they survey the parents. So it's kind of, Jimmy, take this letter home to your mum and your mum and your dad, right, and get them to fill it in for us, right? I don't know if that happens much, but that sounds to me that's what they did, right? So they randomly selected 500 students from whatever, Kitsap County, and those students took a letter home to their mum. Now, what is the population of interest in this story? Who are they interested in finding out? Do they like to spend, or would you be in favour of spending tax money, more tax money? There's a choice. Who is it? You just have to know where to look in the information. That's where I'm looking. So who are they interested in? All the local taxpayers. Now, the way they collected that sample is a bad sample. For instance, if you don't have any kids, will you ever get one of those letters so you can put your opinion on it? No. If you're homeschooling your kid, which means that you pay the taxes, but you don't get the benefit of sending them to school, you will not get one of those letters. In fact, the only people who get those letters will be taxpayers who have children at high school. Can you see that would bias the return? I'm having a guess that people who have children at school wouldn't be against more money being spent on their kids. Would that be a reasonable assumption? More often than not. And so when the government does things like that, can you see why they chose the sample they chose? Because when they start and the politicians start doing their spiel, won't they say 80% of the taxpayers are in favor of this idea? So why are you against it? You're obviously an evil person. Is it 80%? Well, it's 80% of the people who you asked, but did you ask a fair representative group of people? No. So that's the thing you have to watch out for. Now, it talks about a term called sampling frame. Please tell me I've told you what a sampling frame is. If not, I'll tell you right now. Okay, a sampling frame are the people you get your sample from. It should be your population, right? But it isn't always. Isn't the sampling frame here those people? Not the sample, that's the sample. The sampling frame is that one, right? You only pick people who had kids, right, at the high school. And then they go and they say, explain what's wrong with that. Well, we've already talked about some of them. Don't you not get everybody that you would be interested in that sample, right? You don't get people without kids that are taxpayers. You don't get homeschooled parents as well, right? And probably some others. I'll leave that one, I think. It's boring anyway. Oh, here's some choices. Self-selected and convenience. To assess passenger satisfaction, an airline distributed questionnaires to 100 passengers in the airline's frequent flyer lounge. All 100 individuals responded, and 95 of them, right, said that they had a high degree of satisfaction with that airline. What kind of convenience or self-selected? You gotta be careful. Think like you're a lawyer.
I would say it's a convenience because they're already riding the airline.
Yeah, I think they did it because it was easy. Do you know if it was self-selected? Wouldn't they have, I know, a counter somewhere near one of the airports, right? Take one of these and fill them in if you feel like it. That would be an example of self-selected. In other words, I had to decide to pick it up and fill it in, right? That's what a self-selected would be. A convenience sample is one of those, we did it because it's easy. Isn't it easy just to go out? Oh, do you know why they probably went to that particular place? Aren't you likely to get people who like the airline because they're in the frequent flyer lounge? Doesn't that mean that they use that airline a lot? Right. If you had a lounge which doesn't exist called the infrequent flyer lounge, where people who don't use that airline a lot, wouldn't you might get a different answer? Now, in a lot of these questions, they are perhaps should be phrased better, but you know you get 5 guesses, so if you don't like the first one, isn't it the other one? So let's jump. Oh, here's a whole story. That's a nice story, but I don't want to get into it. Too long to read. Here's 1.6. A popular Sunday newspaper magazine often includes a yes or no survey question, such as, do you think there is too much violence on TV? Or do you think parents should use physical discipline? Or whatever the question is. And readers are then asked to send their answers to the magazine, and then the next, magazine production has 80% of people think X, Y, or Z, right? They use the results. Now, the way this is done, you got the magazine, and at the bottom of the magazine, I guess there might be a little cut-off thing. You could tear it and you post it, right? Whatever way they do it. Yes, I believe this, or no, I don't. What kind of sample is that? And the reason some of these are vague, I can see 2 different answers that I would think are reasonable.
I feel like it's the self-selected sample.
I agree with you, because don't you decide to send in your answer or not? That's essentially self-selected as I choose to do this survey, or I choose not to, right? You don't give them it directly, right? That would be slightly different. What would be the other one that I would go for in this one? Although I'm pretty sure that's one they wanted. I think it's convenient, isn't it? Just easy to say, yeah, you do all the work, right? You send me the letter, you tell me what you've got. And it would, a better version of that, wouldn't it be go to this website and vote yes or no? That would be a little bit easier on the person to do, but it's convenient. And then it says, do you think the results of this poll represent the opinion of all the readers? And there are 5 sentences, and normally I don't do this because it takes too long, but I think this time I will. Here are what it is. Is it probably right or maybe not? Give you a chance to, I'll read them out, maybe that's quicker. Probably, since the sample is random, the result should be representative of the population of readers. Maybe not, since the questions asked in the survey are unlikely to be of any interest to most people. Maybe not, since the magazine used the most convenient sample by just sampling their own readers. So I'm assuming that they're pushing the convenience one there. Maybe not, since the readers who feel more strongly about the issues are more likely to respond. And the last one is probably, since it is likely that majority of magazine readers are parents and will want to respond to the survey. Slightly subjective, but I've committed. Which one of those 5? 1, 2, 3, 4, or 5 do you want to go? Right, Robert, you've picked 4. Tell me why.
And it's a confirmation bias. The readers are going to be, if the magazine chose the readers are going to, if they're strongly in favor of it, they're going to be put in for what they believe. So it's going to be biased in that regard.
It's giving an example of what he's getting at there. Do you know if you have a box and it's a box where you put complaints or praise? You know those kind of boxes we put a little comment and you stick it in a box, you know, to do with service. Do you know most people, it's just human nature, tend to complain more than they praise. And so when you look at that box, even if the restaurant's doing a great job, there are normally more complaint letters, like this didn't get done, or that soup wasn't the right flavor, or whatever it is, then yeah, this was excellent. And that's just human nature. Don't you tend to only get out of your seat if something really bugs you to the point where, yeah, I hate that, I'm putting my vote in, you're not going, you know, whatever. And that's human nature. We tend to do that. Okay, we got 8 here. Suppose listeners to a late night radio talk show were asked to call and report and say whether or not they'd seen a ghost. What kind of sample is that? You can almost pick convenient sample for all of these. So let's just take that one off the plate, right? What's left?
I believe it's another self-selected sample because you actually have to dial number, call, and say whether or not.
Yeah, I would think so.
Could it be a cluster sample as well?
To be a cluster sample, you'd have to have. No, I can't see how that would be. To be a cluster sample, it'd have to be like a nationally broadcasted radio, and they only said we only want 50 callers from New York, and we only want 50 callers from Alaska. Right? You actually put them in clusters and said, look, do it that way. So I wouldn't call it for a cluster. That's a very specific one. This one I like. Medical tests, such as those for detecting HIV, sometimes concerns very sensitive information that people do not want to give their names. Okay. When they take the telephone. In some instances, a person taking such a medical test is given a number or a code so that they can run the results. So obviously, if they, you know, we don't need to know who you are, right? But we need to contact you to tell you whether it was positive or negative, right? They've got to do that. I don't know if the tests now are like instantaneous where they can tell you, you know, you go in and then they come back and say, you know, the answer. So in this case, they need to do that. And they say, explain whether this procedure is an example of anonymous testing or confidential testing. Now they sound the same, but they're not quite. So I go in and they call me patient number 123. Right? And I guess I give them my phone number or my email address, right? And then 4 days later, I get a phone call or I get an email from them. right? That's kind of how it's going to work. Is that anonymous or confidential? Because it's only one of them. Nobody want to commit?
I feel like it's confidential.
Good. Why? You're right.
I am. Oh wow. I feel like
Don't
it's
look so surprised. You're right. You had a 50% chance of guessing, if nothing else, right? But that's not why you chose it.
no, I feel like it's more confidential because it has sensitive information in it, and it still has sensitive information, but it's not always linked to a name. But they still have the sensitive information. It's like it's hard to rationalize, but I understand it.
Okay, that makes sense. For this test, if this was a test question, you would have got it right. Okay. Here's my take on the same thing to try and show you the difference. For them to give me back the results, don't they need to contact me? But they're contacting me in such a way that no one else except them and me know about it. So there is a confidentiality thing going on. Anonymous wouldn't work, because if it was anonymous, they wouldn't know who I was, nor would they be able to contact me. You know, like if I fill in a questionnaire and I stick it in a box and I shake it with all the other ones, you don't know which questionnaire I just answered. So if I had 100 people getting an HIV test, but they didn't know which HIV test matched with which person, can you see the anonymity of it would make it a pointless thing? Don't you need some kind of way to link the test with the person? But you want to do it in such a way that it's very confidential. So that would be my argument for the confidentiality part. Now, I know what you're thinking, but the person is anonymous. You're right, the person is anonymous, but that's not the main thing, right? Isn't the main thing that you know who the person is, whether the person has a name that you know or not? There is a link, and that's what makes it different, in my opinion. Although if you've got a lawyer in here, they may well totally disagree with this. One of the fun things and the frustrating things about statistics is the fact that it's not like you solve an equation, right? X equals 2, everybody in the universe, if it's the same equation, right, we all agree. Can you see in statistics, when you start arguing about nuances, that you might not see the same nuance that I see, right? And that gets a little bit gray. Okay, look at this huge one. In a particularly difficult to measure information on behavior that is sensitive, risky, or illegal. In an article and they give you its full description, which was done in 1995, and they looked at male adolescents, that's people in the age group 15 to 19. The respondents were randomly assigned to answer a survey using a traditional paper method. So 368 of them, or by using a computer. I'm assuming that's the other half. They're not the same size, but that's fine. The paper questionnaire was filled out, sealed in an envelope, returned to the person who was surveying this, collecting it, but was accompanied by an identifying code number. So on the outside, you were number 147, and the next one was 127, right? Things like that. The computer method included listening to questions through headphones, then recording the answers onto a laptop computer. The authors believed that this second method would allow the respondents to feel that their responses were more private. In particular, the respondents would not read who need to have the paper version read it to them, whereas the audio computer method allowed complete self-administration of the study. Try to read that again. I know it's, let's say you may not be able to read, and if you gave them the written one, they had to read out the questions to them. So I think this is a very a subgroup of male adolescents. You would hope that 100% of adolescents are literate, right, can read, but that isn't, nothing is 100%, right? There's going to be a certain percentage. I can see what the problem is here before I go into this. There is going to be some problems. If you can't read and the person reads the question out to you, do you think that person's going to be honest if it's something very sensitive? Would you agree there'd be a problem with getting good data? I think that's where the main problem is now I've read that story. Now, on a computer, you put headphones on, the guy speaks the question, you know, it's a robot, right? It's controlled, it just talks it to you, and you hit 1 for yes and 2 for no, and you're finished. Can you see that that helps a lot with the anonymity of it and makes it easier all round? So based on what I've read in that story, although there's a lot more that I haven't read, would you agree that it's probably going to be more successful with the computer responses than it is with the written responses, where some people have to have them read to them? Now, the people who didn't need it read to them, I have a problem with them sticking a code number on the front of the envelope or on the document. Would you agree that you wouldn't you be happier if there was none, no code of any kind, anywhere in this process? Now, on a computer, you don't need the code, right? Doesn't the answer go straight in and nobody knows what the heck it came from, I guess? Even although the people who have it might have a code, you don't know there's one there. So that's another reason why I'm kicking out the written one and I'm more in favor of the computer one, right? Has anybody got any other ideas of what's going on here? Any other reflections? Then we are good. And I have just finished and it's 12:50. I am too cool for high school. I am just good. Right. When I see you tomorrow, since we are nice and finished, I'll obviously be open for homework questions, but most of tomorrow is going to deal with your test and what to expect and how it's going to run. So that's what I want to spend tomorrow on. Will you use your last name when you do your sign in?